Based on the information provided, the area containing the diesel tanks and pit is not classified as a Class 1 Division 2 hazardous location. Diesel is classified as a Class Roman 3 flammable liquid, which is not defined as a Class 1 hazardous material within the National Electrical Code. Since the area is not classified as hazardous, the electrical equipment and conduit in a pit do not require explosion-proof construction. However, the following general electrical installation requirements apply. Firstly, equipment should be suitable for the environmental conditions, for example moisture and temperature. Secondly, conduit should be securely supported and protected from physical damage. And thirdly, wiring should be securely installed and protected from damage. While the pit area may not be classified as hazardous, it is important to consider the following additional factors related to the conveyor motor. Firstly, heat generation. Conveyor motors can generate heat during operation, which could potentially create a hazard if located near combustible materials. Secondly, lubrication. The conveyor motor may require lubrication, which could introduce a potential ignition source. And thirdly, maintenance. Regular maintenance and inspection of the conveyor motor is crucial to ensure its safe operation. To ensure the safety of the installation, it is recommended to firstly install the conveyor motor in a well-ventilated area, away from flammable materials. Secondly, use a motor with an appropriate thermal protection device to prevent overheating. Thirdly, lubricate the motor regularly using appropriate materials and methods. And fourthly, inspect and maintain the motor and surrounding area regularly for potential hazards. By following these precautions, you can help ensure the safe operation of the conveyor motor in the pit, even though the area is not classified as hazardous. It's crucial to understand the classifications of hazardous locations as defined by the National Electrical Code, or NEC. These classifications dictate the type of electrical equipment and wiring methods required to prevent explosions and fires. Class 1 locations involve flammable gases or vapors, Class 2 locations involve combustible dust, and Class 3 locations involve ignitable fibers or flames. Within each class, divisions further categorize the likelihood of the hazardous material being present. Division 1 indicates that the hazardous material is normally present or may be present frequently, while Division 2 indicates that the hazardous material is present only under abnormal conditions. In this scenario, the key determination is whether the presence of diesel fuel classifies a pit area as a hazardous location. Diesel fuel, while combustible, is generally classified as a Class Roman 3 flammable liquid due to its relatively low vapor pressure and high flash point. This means it doesn't readily produce flammable vapors under normal ambient conditions, unlike gasoline or other Class 1 flammable liquids. As a result, the NEC doesn't typically classify areas where only diesel fuel is handled as Class 1 hazardous locations unless specific circumstances, such as poor ventilation or elevated temperatures, lead to the formation of flammable vapors. Since the manufacturing facility is air-conditioned and the ambient temperature is maintained at or below 75 degrees Fahrenheit, the likelihood of diesel fuel producing flammable vapors is significantly reduced. Therefore, it's reasonable to conclude that the pit area is not a Class 1 Division 2 hazardous location. However, even though the area isn't classified as hazardous, it's still essential to adhere to general electrical safety practices. This includes selecting electrical equipment that's suitable for the environmental conditions such as moisture and temperature. Motors and other electrical devices should be rated for the expected operating temperature and humidity levels. Wiring and conduit should be installed in accordance with the NEC to prevent physical damage and ensure proper grounding. All electrical connections should be tight and secure to minimize the risk of arcing or overheating. The conveyor motor itself presents some specific considerations. Motors generate heat during operation, and this heat could potentially ignite combustible materials if the motor is located in close proximity to them. Therefore, it's best practice to install the motor in a well-ventilated area, away from any readily combustible substances. Using a motor with a built-in thermal overload protection device is also recommended. This device will automatically shut off the motor if it overheats, preventing a potential fire hazard. Lubrication is another important factor to consider. Motors require regular lubrication to ensure smooth operation and prevent excessive wear. However, some lubricants are flammable and could pose an ignition hazard if they come into contact with hot surfaces or electrical sparks. Therefore, it's essential to use a lubricant that's specifically designed for electric motors and has a high flash point. The lubricant should also be applied carefully to avoid spills or leaks. Regular maintenance and inspection of the conveyor motor are crucial for ensuring its safe operation. This includes checking for loose connections, worn wiring, damaged insulation, and any signs of overheating. The motor should also be cleaned regularly to remove dust and debris, which can contribute to overheating. Any necessary repairs or replacement should be performed by a qualified electrician. In summary, while the pit area near the diesel dispensing tanks doesn't likely require explosion-proof electrical equipment, it's still important to follow all applicable electrical codes and safety practices. By selecting appropriate equipment, installing it properly, and maintaining it regularly, you can minimize the risk of electrical hazards and ensure a safe working environment. Remember to consult with a qualified electrical engineer or inspector to ensure that your installation meets all applicable requirements. Let's elaborate on specific aspects of electrical installations in areas where diesel fuel is handled, even if they aren't classified as hazardous locations, focusing on practical considerations and code compliance. Firstly, consider the selection of electrical enclosures. While explosion-proof enclosures might not be mandatory, it's still wise to choose enclosures that offer a degree of protection against dust, moisture, and physical damage. NEMA, or National Electrical Manufacturers Association, ratings provide a standardized system for classifying the environmental protection provided by electrical enclosures. For example, a NEMA 4 enclosure offers protection against splashing water, rain, and hose-directed water, while a NEMA 4X enclosure adds resistance to corrosion. The specific NEMA rating required will depend on the environment in the pit area. If the area is subject to frequent washdowns or exposure to corrosive substances, a higher NEMA rating might be necessary. Secondly, wiring methods are an important aspect. Even in non-hazardous locations, wiring should be installed in accordance with the NEC to ensure mechanical protection and prevent electrical faults. Rigid metal conduit, or RMC, and intermediate metal conduit, or IMC, are common choices for providing robust protection for wiring in industrial environments. Electrical metallic tubing, or IMT, is another option, but is generally less resistant to physical damage than RMC or IMC. Regardless of the conduit type used, it should be properly supported and secured to prevent stress on the wiring. Conduit fitting should also be selected to match the conduit type and provide a watertight or dust-tight seal. Thirdly, consider grounding and bonding. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the proper operation of electrical equipment. All metal enclosures, conduit, and equipment should be bonded together to create a low-impedance path for fault currents. This helps to ensure that overcurrent protective devices, such as circuit breakers or fuses, will trip quickly in the event of a ground fault. The grounding system should be designed and installed in accordance with NEC Article 250. Fourthly, overcurrent protection should be addressed. Circuit breakers or fuses should be installed to protect electrical circuits from overloads and short circuits. The size of the overcurrent protection device should be selected based on the ampacity of the conductors and the rating of the equipment being protected. It's important to consult the NEC to determine the appropriate overcurrent protection requirements for specific applications. Fifthly, lighting must be considered. Adequate lighting is essential for safe operation and maintenance in the pit area. Light fixtures should be selected to provide sufficient illumination without creating glare or shadows. Enclosed and gasketed light fixtures are recommended to protect the lamps from dust and moisture. If the pit area is subject to flammable vapors, even if it's not classified as a hazardous location, it's wise to use light fixtures that are rated for use in damp or wet locations. Sixthly, motor control is necessary. The conveyor motor will require a motor controller to start, stop, and protect the motor. The motor controller should be sized appropriately for the motor horsepower and voltage. It should also include overload protection to prevent the motor from overheating. A disconnect switch should be installed near the motor controller to provide a means of disconnecting power to the motor for maintenance or repair. Seventhly, emergency shutdown implementation is critical. Consider incorporating an emergency shutdown system that can quickly de-energize the conveyor motor and other electrical equipment in the pit area in the event of an emergency. This system could include strategically located emergency stop buttons that can be easily accessed by personnel in the area. The emergency shutdown system should be designed to fail safe, meaning that it will automatically de-energize the equipment if there's a power failure or a fault in the system. Eighthly, regular inspections are required. Regular electrical inspections are essential for identifying and correcting potential hazards before they lead to accidents or equipment failures. Inspections should be performed by a qualified electrician who is familiar with the NEC and other applicable standards. The inspection should include a visual examination of all electrical equipment, wiring, and connections. Electrical tests should also be performed to verify the integrity of the grounding system and the proper operation of overcurrent protection devices. Ninthly, documentation and labeling is important. Maintain accurate documentation of all electrical equipment, wiring, and grounding systems in the pit area. This documentation should include circuit diagrams, equipment specifications, and inspection records. Label all electrical panels, disconnect switches, and equipment with clear and concise markings to identify their function and voltage. Proper documentation and labeling can help to prevent confusion and errors during maintenance and repair. Tenthly, training is critical. Provide adequate training to all personnel who work in or around the pit area. This training should include instruction on electrical safety practices, hazard recognition, and emergency procedures. Personnel should be trained to recognize and report any potential electrical hazards, such as damaged wiring, loose connections, or malfunctioning equipment. By implementing these practical considerations and adhering to the NEC, you can create a safe and reliable electrical installation in the pit area, even if it's not classified as a hazardous location. Remember to consult with a qualified electrical engineer or inspector to ensure that your installation meets all applicable requirements. Let's delve a bit deeper into some specific aspects of motor selection and protection, as these are critical for ensuring the safe and reliable operation of the conveyor system. Firstly, regarding motor enclosure types, the motor enclosure protects the internal components of the motor from the environment. Several enclosure types are available, each offering different levels of protection. Open drip-proof or odd motors are suitable for clean, dry environments where the motor is protected from falling liquids. Totally enclosed fan-cooled or TEFC motors are designed for more demanding environments where the motor is exposed to dust, moisture, or other contaminants. Explosion-proof motors are required for hazardous locations where flammable gases or vapors are present. In this case, since the area is not classified as hazardous, a TEFC motor would likely be a suitable choice, providing adequate protection against dust and moisture. Secondly, motor insulation classes are a crucial consideration. The motor insulation class indicates the maximum temperature that the motor windings can withstand without degradation. Common insulation classes include Class A, Class B, Class F, and Class H. Higher insulation classes can withstand higher temperatures, making them suitable for more demanding applications. The appropriate insulation class for the conveyor motor will depend on the expected operating temperature and the motor's duty cycle. In general, it's best to choose a motor with a higher insulation class than required to provide a margin of safety. Thirdly, thermal overload protection is a must. Thermal overload protection is essential for preventing motor damage due to overloads. Overloads occur when the motor is subjected to excessive current, which can cause the motor windings to overheat and fail. Thermal overload relays, ALs, are designed to protect motors from overloads by monitoring the motor current and tripping the circuit if the current exceeds a predetermined threshold. OL are typically installed in the motor starter or controller. Fourthly, short-circuit protection is non-negotiable. Short-circuit protection is necessary to protect the motor and the electrical system from damage due to short circuits. Short circuits occur when there is a direct connection between two or more conductors, resulting in a very high current flow. Fuses or circuit breakers are used to provide short circuit protection. The size of the fuse or circuit breaker should be selected based on the motor's full load current and the NEC requirements. Fifthly, grounding is required. Proper grounding is essential for preventing electrical shock hazards and ensuring the proper operation of the motor. The motor frame should be grounded to provide a low impedance path for fault current. The grounding conductor should be sized in accordance with the NEC. Sixthly, vibration monitoring and mitigation are important. Excessive vibration can damage the motor and other components of the conveyor system. Vibration can be caused by imbalances in the motor rotor, misalignment of couplings, or worn bearings. Vibration monitoring systems can be used to detect excessive vibration and alert personnel to potential problems. Vibration can be mitigated by balancing the motor rotor, aligning couplings, and replacing worn bearings. Seventhly, regular maintenance is key. Regular maintenance is essential for ensuring the safe and reliable operation of the conveyor motor. Maintenance tasks should include lubricating bearings, checking for loose connections, inspecting wiring, and cleaning the motor. A preventative maintenance schedule should be established and followed to ensure that all maintenance tasks are performed on a timely basis. Eighthly, documentation and record keeping is a must. Maintain accurate documentation of all motor specifications, installation details, and maintenance records. This documentation can be helpful for troubleshooting problems and planning future maintenance activities. Ninthly, training is crucial. Provide adequate training to all personnel who operate and maintain the conveyor motor. This training should include instruction on motor safety, operation, and maintenance procedures. Personnel should be trained to recognize and report any potential problems with the motor. Tenthly, energy efficiency is also important. Consider using energy-efficient motors to reduce energy consumption and operating costs. Energy-efficient motors are designed to operate at higher efficiencies than standard motors, which can result in significant energy savings over the motor's lifespan. Energy-efficient motors may also qualify for rebates from local utilities. By paying careful attention to motor selection, protection, and maintenance, you can ensure the safe and reliable operation of the conveyor system and minimize the risk of motor failures. Remember to consult with a qualified electrical engineer or technician to ensure that your motor installation meets all applicable requirements.